Hello everyone, this is Isaac from Engineered Personal Tutoring, and today we're going to go over a statically indeterminate problem. And as always, it is easier if you have a cheat sheet to follow. So I've included a cheat sheet in the description of the video. You can download it, and I'm going to be referring to it as I solve the problem. Alright, so going into it, number one from the cheat sheet is overall statics equilibrium equation. So in this case, number one is the sum of forces in the Fy direction, which will be equal to 0, okay? And we have these reaction forces that are in tension due to that fixed support, okay? So we have Ra, and the reason why that's positive is because we're assuming up, it's the positive direction. So we have Ra minus 800 minus 1,000 newtons minus Re. So if we simplify that, it'll be Ra minus 1800 minus Re equal to 0. Okay, so that's number one. Number two is to take cuts when there's a change. So when I refer to a change, there's three different changes. It could be an external force applied, it could be when the material changes, or when the cross-sectional area changes. So if we start at A, and as we go down to B, there is an external force, so we're going to take a cut right before B, and then as we go down to C, the cross-sectional area changes, so then we're going to take another cut, and then as we go down to D, we have an external force, okay, and then we have another force that'll be applied, which is the reaction force, so we're going to take a cut right at E. Alright, so number two is done. Now we are going to write a displacement equation based on the chosen cuts, which is delta, the sums of the deltas displacements is equal to sums of the PL over EAs, which is equal to 0. Okay, so number three, we have delta, sum of delta is equal to 0, which that means the sum of AB plus delta BC plus delta CD plus delta DE. Okay, so all is equal to 0. And now, in order to get those delta equations, we're going to draw free body diagrams, which is step number 4. And step number 4 is to draw free body diagrams from each cuts. And then underneath that, we're going to find the internal force of each cut. And then next, find the delta equation, the displacement equation for each cut. So let's go ahead and draw a free body diagram with the first one. Okay, so that is AB. The cross-sectional area is still A1, okay, and it goes up. Sorry, I'm going to switch these around. So this is going to be A2, and this is going to be A1. The reason that is because A2 is bigger than A1, so that makes sense visually, okay. So this is the area 2, so we got a reaction force here, Ra, okay, and then we have a internal force here of PAB, right? And then this is an area is A2, as we just talked about. So sums of forces in the y direction is equal to 0, which is equal to Ra minus PAB. So then PAB is just equal to Ra. And since we know that's the case, then we can do our delta AB equation. So delta AB is equal to PABL over AE, which is just equal to RAL over AE. And that A is A2 in this case. Alright, and now we're going to move on to BC. So BC, we have internal force here of PAB, right, because this is B and this is C, and then we're going to have another internal force here of PBC, and then we also have that force of 800 newtons applied at B. Alright, now sums of forces in Fy is equal to 0, which is equal to PAB minus 800 minus PBC. And I'm sorry if you hear that bird. It is going crazy right outside my window. So next we do solve for PBC. PBC is equal to PAB minus 800, right? And then we do know that PAB is also just equal to RA, so I'm going to include that in the delta equation. So delta BC is equal to PBCL over, and this area here is also A2, so it's equal to A2E, which is equal to RA minus 800 L over A2E. Alright, now we're going to move on to CD. So then we have PBC here, okay, and then we have just a external force of PCD, and this is an area of A1. So sum in the Fy is equal to 0, which is equal to PBC minus PCD, and PCD is just equal to PBC. Then next we got delta CD is equal to PBC, which is just RA. I'm going to write it out first. PBC L of PCD L over A1E, which in that case, that is equal to PBC, which then PBC is just RA minus 800 L over A1E. And then next, let's draw out DE. So this is DE. We have a force of PCD, and then 1,000 newtons applied at D. And then we also have RE down here, but not yet. We have a PDE here. Okay, and then this is A1 as well. So sums of forces in Y is equal to 0. It's equal to PCD minus 1,000 newtons minus PDE, which that means that sigma DE is equal to, well, we got to solve for PDE first. So PDE is equal to PCD minus 1,000, which that means that PCD is just RA minus 800, so this is RA minus 1,800. So sigma DE is equal to, I'm going to move it down so we got some space here. PDE L over A1E, which is equal to, so PDE is RA minus 1800 L over A1E. Alright, so next we're going to go to step 4, which is, sorry, we just finished step 4. So we're going to go to step 5, which is solve the displacement equation in step 3 and for reaction force. So we have all these equations here. So we have delta AB, delta BC, delta CD, and delta DE. So let's go and plug into this equation. So we got RAL A2E plus RA minus 800 L over A2E plus another RA minus 800 L over A1E plus RA minus 1800 L over A1E. Okay. Now in this problem, we know that A2 is equal to 9 times 10 to the negative 4th meter squared, and A1 is equal to 3 times 10 to the negative 4th meter squared. So we can just plug in this relationship that A2 is equal to 3A1. All right, so that's what I'm going to do. So I'm going to plug that into this equation. So we get RAL is equal to 3A1E plus RA minus 800 L over 3A1E plus RA minus 800 A1E plus another RA minus 1800 L over A1E. Alright, and then next, since we have L, A1, and E in all these, I'm going to take that out of the equation. So L, A1, E. So then we're just going to get RA over 3 plus RA over 3 minus 800 over 3 plus RA minus 800 plus RA minus 1800. Okay. And that is all equal to 0. So since L over A1 over E can equal 0, I'm just going to focus on this part of the equation. And next we're going to simplify it a little bit. So combining the RAs, we have, I'm going to use my calculator here, 1/3 plus 1/3 plus 2 RAs. So we have 2.667 RA, okay, which is equal to 1800 plus 800 plus another 800 divided by 3, which is 2866.67. Okay, and then RA should just be that, 2866.67 newtons divided by 2.666. So let's go ahead and do that. RA is equal to 1075 newtons in tension. And the reason why it's in tension is because it's positive. Alright, so now we finished step 5, so now we're going to do step 6, which is solve for the other reaction force from step 1. So step 1, we had the equation RA minus 1800 minus RE is equal to 0. So let's go ahead and just do RE, that's right down here in around space. RE is equal to RA minus 1800. So then RE is just equal to, and it's really coming down raining now. So let's go ahead and finish this up. It's 1075 minus 1800, which is equal to negative 725 newtons. 725 newtons. So that is RE is equal to 725 newtons in compression. Alright, so that's the answer to this problem. Please let me know if you have any questions, and thanks for watching.